By the end of this video, you will be able to relate the mole concept to Avogadro's number, apply the mole concept to represent particles and vice versa, apply the mole concept in getting mass or vice versa. Have you ever tried to count every granule of rice in your kitchen? Or even sell a chicken egg individually? Not that easy, right? Can we measure or handle a dozen, gross or giga of atoms? To figure out the countless things in this world, we used mole. The mole concept is a convenient method of expressing the amount of a substance. When dealing with particles at an atomic level, even 1 gram of a pure element is known to contain a huge number of atoms. This is where the mole concept is widely used. It primarily focuses on the unit known as mole, which is a count of a very large number of particles. Take note, mole is the SI unit used to measure the amount of substance. Avogadro's number is the number of representative particles in a mole, which is equal to 6.02 times 10 to the power of 23. Moles can be used to count representative particles. The representative particles can be atoms, molecules, ions, and formula units. The number 6.02 times 10 to the power of 23 is popularly known as the Avogadro constant or Avogadro's number, and is often denoted by the symbol Na. Avogadro's number was formulated and was named after Lorenzo Romano Amedeo Carlo Avogadro. For example, 1 mole of a pure carbon-12 will have a mass of 12.011 grams and will contain Avogadro constant of 6.02 times 10 to the power of 23. The number of moles of a substance in a given pure sample can be represented by the following formula. Small n equals capital N divided by Na, where small n is the number of moles of the substance, capital N is the total number of elementary entities in the sample, and Na is the Avogadro constant, that is 6.02 times 10 to the power of 23. And now, let's have sample problems. Sample problem number 1. How many molecules are there in 4 moles of table salt? To answer this question, we have to consider this. 1 mole is equal to 6.02 times 10 to the power of 23 particles. Using the dimensional analysis approach, you will be able to convert the number of moles to its equivalent amount in the number of particles. 4 moles of table salt times 6.02 times 10 to the power of 23 molecules of table salt divided by 1 mole of table salt is equal to 2.41 times 10 to the power of 24 molecules of table salt. Sample problem number 2. How many mango seeds are equal to 5 moles of mango seeds? Again, to answer this question, we have to consider this. 1 mole is equal to 6.02 times 10 to the power of 23 particles. 5 moles mango seeds times 6.02 times 10 to the power of 23 mango seeds divided by 1 mole of mango seeds, which is equal to 3.01 times 10 to the power of 24 mango seeds. Sample problem number 3. How many moles of copper are in 6 million atoms of copper? Again, consider this. 1 mole is equal to 6.02 times 10 to the power of 23 particles. 6 million atoms of copper times 1 mole of copper divided by 6.02 times 10 to the power of 23 atoms of copper is equal to 9.97 times 10 to the power of negative 18 moles of copper. Sample problem number 4. How many grams are in a sample containing 2.71 times 10 to the power of 24 atoms of iron? We are going to refer to the periodic table of elements in getting the atomic mass of iron. So the atomic mass of iron is 55.845 grams. Now to solve this, we have 2.71 times 10 to the power of 24 atoms of iron times 55.845 grams of iron divided by 6.02 times 10 to the power of 23 atoms of iron is equal to 251.3 grams of iron. Sample problem number 5. How many atoms are in a 3 grams sample of gold? Consider 1 mole is equal to 6.02 times 10 to the power of 23 particles, and the atomic mass of gold is 196.967 grams. Okay, let's solve. 3 grams of gold times 6.02 times 10 to the power of 23 atoms of gold divided by 196.967 grams of gold is equal to 9.17 times 10 to the power of 21 atoms of gold. Sample problem number 6. Aspirin has a chemical formula of C9H8O4. What is the mass of 0.80 mole of aspirin? Before we solve this problem, let us get the total mass of aspirin first. So, there are 9 atoms of carbon. We multiply these 9 atoms by the atomic mass of carbon, which is 12.011 grams, and the product is equal to 108.099 grams. There are 8 atoms of hydrogen. We multiply these 8 atoms by the atomic mass of hydrogen, which is 1.008 grams, and the product is equal to 8.064 grams. There are 4 atoms of oxygen. We multiply these 4 atoms by the atomic mass of oxygen, which is 15.999 grams, and the product is equal to 63.996 grams. And now, we're going to get the sum of the 3 masses. 108.099 grams plus 8.064 grams plus 63.996 grams is equal to 180.159 grams aspirin. So, 0.80 mole of aspirin times 180.159 grams of aspirin divided by 1 mole of aspirin is equal to 144.127 grams of aspirin.